topic. Rationalize the denominator. So you'll want to make sure to write out these directions. Those vocab words are really important. What it means kind of a little bit more easily understandably is no radicals in the denominator of our fraction. So we need to think about how to get the square root out of our fraction. And the trick for this is I'm allowed to do anything to the top as long as I do it to the bottom, right? If I multiply something to my numerator, I have to do the same to my denominator. So the only way to change, to adjust this fraction without changing its value is multiplying. So what times the root 7 makes it like not a square root anymore? Well, I know a square root of 7 times the square root of 7. It's the square root of 49, which is just 7. Another way to think about that is if you square a square root, the square root and the squaring, they undo each other, and you just get the 7 out, right? Those both equal 7. So these are two ways to think about it. So if I do multiply the bottom by a square root of 7, I also need to do the top times square root of 7. You're going to have 5 square root 7 on the top. On the bottom, you've got a square root of 7 being squared, right? Those undo each other, as we said. So your final answer is 5 root 7 over 7. And the reasoning for why we do this will become a little bit more clear. Excuse me, sorry about that. It will become a little bit more clear in your pre-calc course. This concept does come up a lot in simplifying during problems. If you're curious, you can also do a quick Google search of what is the value of rationalizing the denominator. So feel free to do a quick Google search if you're curious. Now, the second one is a little bit more complex, right? Before we had 5 over root 7, now I'm adding a 2 to my denominator. So the question you might be asking is, okay, do I do anything differently than before? You might say, okay, well, what if I just do times root 7? Here's the tricky thing. I've got something with 2 pieces, right? It's a binomial. So you want to think about that, what I wrote as distributing. If you distribute it to both, or think about it like an area model, that's going to become 2 root 7 plus root 7 squared, or 2 root 7 plus 7. So you do take care of the square root of 7 on the right side, but then the 2 ends up having a root 7. So this doesn't really work. Right, we can't do that. So the question is, what do I do instead? And so here's where I'm going to illuminate a nice trick for you guys. What we're going to do is we're going to multiply our numerator and denominator. Oops, I'm running out of space. I'm going to kind of slide it a little bit by the conjugate. It's an interesting vocab word. That's like a new vocab word. So the conjugate. So the conjugate of 2 plus root 7 is going to be 2 minus root 7. So notice the conjugate has the same pieces or components. You just change the sign in between. So the question is, why does that work? So let's explore what that distribution box would look like, our area model. So I had 2 plus root 7, right? Notice we have 2 binomials and 2 minus root 7. So think about it more like this, right? With parentheses, that might help you see that distribution. So you can either FOIL that out or use area model. 2 and 2 make 4. 2 and root 7 are going to make 2 root 7. 2 and negative root 7, negative 2 root 7. And then the root 7 and root 7 make a 7, right? That's root 7 squared, which is just 7, and a negative sign in front because 1 was negative. Notice what's really nice. I have a 2 square root of 7 and a negative 2 square root of 7. These are going to cancel out. So this is going to simplify on the bottom to a 4. I'll keep it color-coded so you can see where it comes from, minus a 7. Now notice the reason why that works is because the conjugate creates a difference of squares. Really nice aspect of that. On the top, I'm going to do distribute my 5 to both pieces. So 5 times 2 is 10, and 5 times square root of 7. Okay. And then I'm just going to simplify my denominator because I do want to clean that up, the 4 minus 7, right? I can simplify that a little bit. So 4 minus 7, that's going to be a negative 3. And this is a little bit unconventional, how we wrote it with the negative sign. If you want to fix that, you can do a negative 1 and multiply that by top and bottom to get a 3 in the bottom. Notice though, if you multiply the negative 1, you will have to distribute it to both pieces. So this is just like a little bit more of what like the generic answer will typically look like. Normally we don't have like a negative sign in the bottom, but both are mathematically the same thing. So I'd accept either answer. Okay. For practice, we've got this problem. So this problem, before you get it to look like this guy, you might have to do a little bit of simplifying using some of your radical rules. So go ahead and pause the video, try it on your own, and unpause when you're ready for checking or need a hint. Okay, and here is your final answer. Notice you did need to rewrite using that quotient idea, and then fix by multiplying by root 7 on top and bottom. If you'd like a couple more practice problems, I'm going to write down 2 more practice problems for us. So here are a couple practice to double check how you're feeling. So I'll make practice problem A. Let's do 1 over root 2 to simplify that denominator. And practice problem B, I'll give you one that's more similar to this guy here, except for I'm going to make the bottom into something like 3 plus root 5, just for some variety, because the first one we did had, actually I want to make it minus, because we had a plus sign in the original problem. And then I want to put something in the numerator. I'm going to put maybe like a 2. Okay, so here are your 2 problems to do for practice. Feel free to unpause when you're ready to check. Okay guys, so there are your final answers to double check. First one should have been a little bit more straightforward. Second one, you are practicing multiplying that by the conjugate again. Notice in this case, because the original problem had a minus, our conjugate has a plus because you have to have 1 plus and 1 minus in order to have that difference of squares work that you see in the green over there in that corner. The difference of squares works out nicely because both of the pieces with the square root of 5 are going to cancel out. One's positive, one's negative. And then all you have is 9 minus 5 or 4. You do also need to distribute that 2 in the numerator to the 3 plus the root 5. I find that putting parentheses kind of helps me keep in mind that distribution and not accidentally partially distribute, but not fully. One tiny thing that you might have noticed was the 6, the 2, and the 4. Those are all even numbers, so we can divide the numerator and the denominator by 2. You don't have to write the 1 in front of the root 5 if you don't want to. I just put that there for cohesiveness. So that's it for today.